Today we are going to talk about triangles. By the end of class, you will be able to determine the base and the height of triangles. Before we get started with the base and the height, I would like to focus on classifying triangles. If you can recall, we classify triangles two different ways, by their sides or by their angles. And combined, you would name a triangle using both the sides and the angles. When we classify by sides, we've got three different options. Equilateral triangles have all sides congruent. That can be modeled by one tick mark each, so they all have matching tick marks. Isosceles triangles have two sides that are congruent, again noted by the same tick marks. These two sides are congruent while this is a different length. And then lastly, we have scalene, and this is where there are no congruent sides. So scalene has three different length sides. Quick reminder here, congruent is going to mean the same length side. So they are the same. So here, three sides are the same. Here, two sides are the same. And here, no sides are the same. Okay, so that's how we classify by sides. Then we can also classify by angles. One kind of triangle is an acute triangle. This is where all angles are less than 90 degrees. This is an acute triangle. If you wanted, you could take a piece of paper or a note card or the corner of some Post-it notes, and you would see that all of the angles are smaller than 90 degrees. Then we have obtuse, and this is where one angle, only one, cannot be more than one angle is larger than 90 degrees. So again, if you take the corner of something, you can see that this angle, this top angle up here, is larger than that 90-degree angle. Again, you can only have one angle that is larger than 90 degrees. And then lastly, we've got our right triangle, and that is where one angle is exactly 90 degrees. So it perfectly fits that corner. Now you have this little box in the corner noting that it's a right triangle, a right angle, when it will be a right angle. If it's 89 degrees or 100 degrees, it's not a right angle. Okay, so it has to be exactly 90 degrees to make it a right triangle. So then what we could do is say, okay, well, this looks like an acute isosceles. So all the angles are less than 90 and two of the side lengths are congruent. Here would be potentially a right scalene. We've got one right angle and then three sides are all different. Okay, so you would combine and match these here. Okay, let's go ahead and, one thing that I want to point out is equilateral triangles have to be acute. Not only are the lengths, those sides congruent here, the same side lengths, their angles then are all the same as well. So that means it has to be acute, since only one angle can be above 90 degrees here and only one angle can be a right angle here. That means all equilateral triangles are acute. All right, let's go ahead and take a look here. We've got some examples and non-examples. Here are appropriate ways to draw the base and height. So this is the base, and then these are all potential heights. A base, height, base, height. These are examples. These are good examples for the base and the height appropriately drawn. These do not have appropriately drawn bases and heights. So, for example, this base is not a height. That's not a height for this base. Not a base and height, not an appropriate base and height. So what I want you to do is you're going to pause the video and you're going to take a look. What do you notice about these three examples? What makes the base and height appropriately drawn? Then I want you to ask yourself, what makes these three different? Wow, so we've got a lot of feedback here, a lot of discussion about that right angle. So we must, just like with parallelograms, our base and height must meet at that right angle. Additionally, that base, or the height, must attach to that base and meet at the opposite angle. So see how this base connects these two angles? That height has to meet the opposite corner, the one that has not yet been used. Does that make sense? So for here, this one is a great start, right? We've got that base, we've got that 90 degree, but it doesn't go to that height of the opposite angle. All right, let's go ahead and take a look down here. We are going to select all statements that are true based on what we saw in our examples and non-examples. So the first one says any side of a triangle can be a base. Is that true or false? That's true. Any side can be a base. You just then will need to adjust where that height is and what that height looks like. That said, there is only one possible height. No, that is not true. There are multiple options for heights. And it depends. Some triangles might only have one option for a height, whereas others might not. It depends on where that base is. You'll see. A height is always one side of a triangle. So again, looking at our examples, here we've got bases that are not sides of the triangle. So that's false. A height that corresponds to a base must be drawn at an acute angle. Is that true or false? Good, that is false. Nice job, guys. It cannot be acute, but it should be drawn at a right angle. That is true. Once we choose a base, there's only one segment that represents the corresponding height. And nope, that's not true. So for example, like we can see up here, this is the one that I would typically go with where it directly connects to that opposite vertex, but all of these are okay. So no, that's not true. And then lastly, a segment representing a height must go through a vertex. And that also is not true. It must meet that height. So for example, this one, it meets the height of my opposite vertex, but it doesn't actually go through it. So if I just drew this, that'd be totally fine. So that is false. All right, we've got 3 triangles down here. What I would like you to do is pause, and you are going to start here. So it says side A is base. So this is your base. Get out a straight edge, so a note card or a ruler or another piece of paper, and draw me a height for A as your base, for B as your base, and C as your base. All right, so go ahead and draw those now. So once again, A is my base here, so I do need it to meet the height of the opposite angle. So typically when the triangles are like this, I just directly draw. I can line up my corner along my base and my other angle, and I just draw it like this. If you did it off to the side somewhere, making those extenders like here, that is fine as well. Looking at B, I would draw an extender here. So if B is my base, I need my base, or excuse me, my height to meet this corner here. So I would actually extend this and then draw, I'm gonna have to do it this way. I would draw it off to the side right here. Again, you need to ask yourself two big questions. Two big questions. Number one is, does it meet your base at 90 degrees? Meet base at 90 degrees. If yes, then you are close to being correct. And then the other piece of that is, it doesn't meet the height, or meet the height of the opposite angle. So if these two things are good, then you're likely correct. If you would like to show me your example, go ahead and we can look at them together. And then lastly, if C is my base, I actually would draw an extender here too. Line up my corner on the base and with the opposite vertex. And there we go with my height.